Oh, it's a jungle out there, 'cause there's statistics everywhere. And here we're going to play with a scenario where we want to test a server. Is it over 250 seconds that it goes down per month? Let's pretend that's like some guideline. And we have a whole bunch of different words here. Let's pick out the pieces that we really need. What are we testing? We're testing if the average time is over 250 seconds. Our last example was a less than, so this time we're going to do a greater than example. That means the null hypothesis is going to be that mu is less than or equal. So we have a mu from the null being 250. And then it says right here, let's assume the actual value is 259. So of all the values in the alternative, that's the one we're going to do the math on. We have our sample size of 12. That's a small sample size, but we did say assume normality, so that's okay. Sigma 50, and an alpha, let's do 0.08 just so that it's not the classic 0.05. To do this one, I'm going to draw just one picture instead of the 3 different separated pictures like we showed last time. I know that my null hypothesis is on the low end at 250 with an alternative hypothesis that's somewhere over on that end of the scale, but I don't know exactly where it lands yet, and I want to draw a really good picture, so I'm going to wait to do my alternative until I have some more information.
I cannot create a great work of art.
I do know I have 8% area here, which gives me a z-score of 1.405. I guess actually this is the lower end. We're looking at a right-tailed test, so I would want 0.08 there to give me 1.405. It needs to be positive to be on the higher end. And I'm going to remember that number and solve for the x-bar. Not the x-bar I got from data, because I don't have any average from data. This is the x-bar critical. Where's the line between fail to reject and reject? Solving for that gives me 270. So if I get an x-bar that's less than 270, it'll be here in the nulls range, and I'll say fail to reject. If I get an x-bar above 270, I'm going to say reject. Let's store that number, partly just because it makes us feel good to see that we're making progress. Now, that shows me where 270 lies on the number line. And I can look at this 259 and try to put it in the right spot on here to make a really good picture. Now I can see this 259 is actually pretty close because the line is clear out at 270. With the null and the alternative being so close together, I bet it's going to be hard to tell they're far apart. I'm guessing our power is not going to be that large. So with this 259 right here, I can draw a picture for the alternative, and I don't need this black curve anymore. This hypothesized null stuff isn't going to be there. So I'm going to try the magic trick of dabbing this to see if I can make the black distribution fade away. Right? Like you can kind of tell it used to be there. Does it show up on that? It shows up on the camera a little bit. So I'm done with the null stuff. Now it's time for the alternative to take over. And I left all this room on that side of the board thinking the alternative was going to end up somewhere over there. And it's pretty close to this side of the board still. There it is with a line right here. This is the line deciding whether we reject or fail to reject. We are looking at a right-tailed test. So the rejection region, which is what the alternative wants you to do, is going to be to the right. This is our power. Power and alpha shade in the same direction. So looking at this, you can probably guess what kind of an answer we get, but let's go ahead and work it out. A z-score with x minus mu over sigma. That gives us 0.78. And I'm going to add that to the list so that it feels like I'm accomplishing something. Now I'm ready to look it up to get power. Our z-score was 0.7814. And flip the side to make it positive, 0.21728. The power, being the area under this curve, is about 21%. And there is our final answer. 21% power, that's not super great. Why is it so low? Well, because the null and the alternative were so close together, it's kind of hard to tell that the null is a lie. So we only have the power to detect that with about a 21% chance.